So up to this particular point in our tutorial, we're able to see a whole lot of models that we're actually being come in contact with, like that of the linear regression, the logistics regression, and that of the decision tree regression. These three, you can say these three models are one of the maybe can say one of the building blocks to many models out there. So, and these three models are the ones that tend to fall into what is actually called that of the overfitting and underfitting. These three models tend to suffer it really more. So, in this video, we are going to look at what is actually that of the overfitting of the machine learning model and what is actually called underfitting. So, I'm basically going to use a simple example to actually explain this. What is actually this underfitting that we're actually talking about? Underfitting occurs when, most of the time, the model learns from a small amount of data. There's no enough data. Like what we have been doing all this while, using just this few amount of data right here to train our machine learning model. At times we even went to the extent of even splitting the data that is not even up to can say 10 rows actually. You're not even up to 10 rows. We still have to split it on top of it and then use it to train and then use it to test. This is prone to model that's being mainly trained on small data are prone to underfitting. The main cause of underfitting is basically when the model actually maybe learn small stuff and then you want to actually use it to implement big things. Just like when a student maybe read things like Jota, maybe read things like maybe small handouts, only Jota, maybe written notes that is found out somewhere, and you want to go and write examination. No, at this point you are in state of underfitting actually, because the information you have at hand is not powerful enough to solve I can say real life scenario or a bigger task. It's as if your element, you use the maths that you studied in primary school to want to actually use it to solve can write the exam in that of the university, or the maths you learned in your elementary class, want to use it to enter and solve university programs. You see that this is actually where underfitting actually becomes into place. We mostly cause when the data is actually small and the model was able to learn small amount of data and then is trying his best to actually test or maybe on a huge data. So the comes to that of the training data. Since it was actually being trained on a small amount of data, the training accuracy is usually low. It's very low because it doesn't really have much data to actually learn from. But in a situation whereby the data is actually that of the linear type of data, is linear, maybe the x and y, maybe two, maybe one x, maybe one input feature, and then maybe one feature that you are going to use to train the model, and then to that of the y, or can say the target, they tend to form that of the maybe a linear graph. You can see that in this, and then you have small amount of maybe like 10 rows to actually train your model. You can see that on the training accuracy, it might perform low, or at times it might perform high, or it all depends on the testing. Definitely is going to give you almost like 100% accuracy. But this is actually one of the big challenge that this is one of the big challenge that you're going to face if you have small amount of data and you want to actually training model. Just imagine you want to predict forest market, and the row of data you have is only that of the 5,000 rows of data you want to predict and analyze market. I can say stock market, or maybe forest market, or maybe football prediction. You can see that this can actually lead to that of the underfitting. Underfitting is a really bad scenario when it comes to machine learning model. A machine learning model that suffer this underfitting, you are going to have issue on a new, maybe when you try to predict a new maybe unseen data, maybe feature data. you are going to really have problems. So which also led us to the next topic, which is actually that of the overfitting. So, but I have an image here that I want us to use to actually explain this of the underfitting and this of overfitting. When you look at underfitting, you can see that the model is when you look at underfitting, it's too simple to explain the variance. Consider the model just try to just dive in directly to them, does not even think or even budging to find any pattern that any pattern that might exist, because the model is actually too simple. Like I said, it's a student that just learned maybe read his jotter and they want to go and prepare for the examination, and so want to go and write the examination, or a student that just only knows basic mathematics or maybe elementary mathematics and they want to go and write a university exam for somebody, consider it's not going to work out. When it comes to this of the overfitting, is far different from this of the underfitting. Overfitting is more like when the models have actually learned too much. When the model have actually learned more than what is required, and now is like I said, you can see down here overfitting was fitting too good to be true. The problem with this overfitting is that when the model is done learning, for maybe the cause of overfitting is due to maybe the model learns so much, like I stated earlier. And also, when the model have actually, when I mean learning too much, you also have all those type of noises. To learn both the noises, inappropriate stuff, just like a student who want to write an exam, just instead of reading maybe the notes or reading some other material that might help the student write the exam, the student went online to get some other maybe the necessary and unnecessary material that can lead to confusion, a whole lot of confusion, inappropriate stuff that can make the student to be confused on that of the examination. So I just make use of this example to make things a little bit easier to understand. Think of overfitting is that when the model have learned more than what is expected to actually learn. But when underfitting is when the model is not being trained really well on enough data. Overfitting when they actually learn too much. When I mean learning too much, learning on unnecessary data, unnecessary noises, unnecessary information that make it to be biasing. So these are kind of, when I mean biasing, deviating from what is actually supposed to be doing exactly. Like when we look at this overfitting, you can see that the line signified the model, how the model was trying all its best to actually fit in on the data. You can see that it was struggling, trying its best to actually fit. This is actually exactly an example of that of the overfitting. But when it comes to this of the appropriate fitting, this is more like the appropriate fitting. The model try its best to classify or can see to maybe to differentiate that of the maybe the X and the O, or to differentiate that of the to classify the information really, really well. So when it comes to this overfitting, underfitting, and appropriate fitting, there's also something called that of the ideal model. Ideal model is just like perfectly fitting, which does not, most of the time, does not actually exist. With this appropriate fitting, when you use students, for example, it's basically more like a student who read the required necessary materials to before enter that of the exam hall. You read things that maybe the notes, maybe the jotter, and things that maybe the lecturer or the class teacher stated in the class, and maybe give out that you should read for the upcoming exam. This is more like the appropriate model. It does what was expected to do. Overfitting is more like when you read some unnecessary data, read extra what is not actually being required, which can make the model to actually be misbehaving, to doing some kind of stuff. And when it comes to this type of model that have overfitted, one of the problems they actually face is that when they come to their training, and when they are training the model, they tend to actually, their accuracy tend to be really, really high. Most of the time, it can reach almost 95 and above %. But when you come to the testing, when you test a new data on it, and then like how we actually did it. Like when you test a new data right here, this is where we actually predicted on that of the new data that we actually predicted, not this one but before this, which is that of the S test and that of the Y test and all those stuff. And then we check the accuracy score, the confusion matrix, the classification report is performing poorly. As you can see that this is trying to tell that the model is actually overfitting. When you check that of the trainings and training data set, where you give it back the training and then try to predict the output, and then you check the accuracy, is rounding up to that of the higher accuracy. But when you give it a new data to actually predict and then you check that of the accuracy, it will going to perform poorly. This is what causes of overfitting actually causes. He learns too much, but using what he learned to actually write the examination, the actual data we want to actually get is, we can look at it as more like that of the examination. To write out of the examination becomes a problem for the model. So this is just basically what is overfitting, underfitting, and appropriate fitting. Because this is appropriate fitting, we don't need to actually explain really much. This diagram, I actually got it online for one side. I think that was geese for geese. I saw this diagram online, so I just say let me use it to explain difference between that of the overfitting and that of the underfitting. The appropriate fitting, like I said, is the right thing to do, but most of the time this appropriate fitting doesn't actually exist. On a nutshell, your model can be overfitting a little bit or is underfitting a little bit, because no model is actually perfect. So what we're actually doing is just to reduce that of the overfitting and underfitting. Appropriate fitting is almost impossible to get. This is more like the ideal fitting, which is almost impossible to get. So we'll just try our best to reduce the overfitting and also to reduce that of the underfitting. So these are basically some of the things you should know. Remember that for underfitting, to solve that of underfitting problem, increase the size of your data. To solve the overfitting problem, pre-process your data really well. So these just basically the two simplest concepts that you can use for this, to handle this for underfitting, and for this overfitting. For underfitting, what you basically need to do is actually to, like I stated earlier, you need to actually increase the number of data you have. Maybe the the features, may add more features, do some feature engineering, increase the number of features, increase the number of data points, rules of data that you are using for your training. Increase it. If you have like 1,000 rules, try to, it all depends on the data, on the task you're actually trying to solve. There's some tasks that require the maximum amount of rules. When it comes to those type of data, maybe those type of situation whereby the maximum, no matter the combination, that's something have to do with combination. Like when it comes to that of tic-tac-toe game, the combination for each of the step might be limited. So kind of thing, it might be subjected to maybe for a particular rule, which is going to work really, really well. It's never going to overfit, or it's not going to underfit. So if it's a kind of, maybe you're predicting football game stuff, increase the number of data that you have. Maybe at least we are looking at least 50,000 rules, which is really, really okay, good to go. For overfitting, reduce some columns, do some feature engineering, like I stated earlier, like can do some feature selection, feature normalization, standard scaling, whole lot of things you can actually do. Maybe select some particular feature that does not contain much noise. Then you can actually make use of this or the feature to handle this overfitting. And then handling overfitting, you can actually get to the get a glimpse of this of appropriate fitting, because to be sincere, appropriate fitting is hard to get, but you can actually tend towards it. So that's just basically what I want to also have ideology on this of the overfitting and underfitting, because when you look at what we have actually done so far, using this small amount of data to train our model is not actually the right thing to actually do, because that's definitely I say that this is basically just tutorial. So I don't want to make things complex by employing larger amount of data for us to actually make use of. So we want us to actually understand the smallest amount of data. Then we can actually then at the end we can actually implement giving it real life data, because very soon we are going to be end with this of the machine learning for the beginner, because what I try to do now is still that of the beginner level. We are going to go into that of intermediate and that of the advanced level. So that's why I just want us to make use of all this small data. But we'll go to that of the advanced level, we definitely will not be having this type of small data. We'll be dealing with, when I mean real life data, that's basically what we'll be dealing with, not this kind of dummy data, I can say simulated type of data. So this video we'll be looking at that of the pipeline, that of the colon transformer. These two guys are basically what we are going to look at in our next video. So in case if you are actually interested on how to automate the pre-processing of your data, the training of the model, everything all in once without losing some data on the way. So this is actually what colon transformer and that of the pipeline actually does. So if that's basically what we'll be looking at in the next video. So find this video anywhere useful. Subscribe is not going to be a problem. So remember, this is a recap of what we actually learned in this video. We talked about that of the underfitting and that of the overfitting and that of the appropriate fitting. We gave an example, not just only example. We did like we are explaining how you can actually solve that for that of the underfitting, and also how to solve for this overfitting and for this appropriate fitting. How to actually, because appropriate fitting is all what we are all fighting for, but doesn't mean that appropriate fitting exists anywhere. Just that we're all trying our best to get to this appropriate fitting. So I make use of students that are for this underfitting, students that just learned maybe read is Jota, or maybe it's kind of other small material, and they want to go and write some big exams. You can see that students learn small information. I want to tackle that or the bigger challenge. You can see that it's not going to go well. It's not going to go well for that or the students. And the student that for small tasks, he read more than what he expected to read, like reading some unnecessary data, some on some stuff that doesn't actually apply to what he wants to, like with the task that is at hand. That is actually where overfitting actually comes in. For while following the what is expected, do everything, that's actually where appropriate fitting comes on. So the cost of underfitting is mainly caused by that of the small amount of data sets that you have, maybe small feature or maybe small data point that you have. For overfitting, this is actually cost most of the time. It's not even the amount of row of data you have. This is actually cost maybe based on the colon that you have. Like I say, when I mean column, yeah, that's actually the features that is put into your data, because the more the feature, the more tendency that some feature might have noises on them. So that is where feature selection actually comes in. And we have looked about this feature selection really, really well by making use of some external stuff that SKLM provide for us to actually handle some of all these features and select the best features out there to use for our data. There's not actually best feature, but feature that tend to perform better than some. So this is actually come to the end of this video. If you find this video useful, subscribe is not going to be able to